This is where a high-tech timekeeper comes in, bringing some really powerful indoor tracking technology right onto the bustling factory floor. The core of this whole thing is called meter-level indoor positioning. The easiest way to think about it is like a super accurate GPS, but one that works inside a building. It uses wireless signals to pinpoint the location of an object, in this case a bundle of fabric, to within about a meter. The bottom line is you can see exactly where everything is all the time.
All right, let's meet the hardware. First up, you've got the brains of the operation, the W25 gateway. Just picture these things as indoor GPS towers. They get installed up on the factory ceiling, and they are constantly listening for signals, creating this invisible tracking grid over the entire production area.
And these gateways have a very specific range. From a pretty standard factory ceiling height of just over 3.6 meters, each one creates a coverage circle with a 14.6 meter radius. Now try to remember that number. It sounds a little technical, I know, but it is so important. And as you'll see in a minute, it creates some pretty big engineering challenges.
So if the gateway is the brain, then the T20 tag is the messenger. This little device gets attached to every single bundle of fabric. This is the thing that's actually moving through the factory, constantly shouting out its location to the gateways up above. It's basically the voice of the t-shirt while it's being made.
And you won't believe how chatty this little messenger is. When a fabric bundle is moving between workstations, its tag sends out a location update every half a second. Every half a second. And even when it's just sitting still, it checks in every 8 seconds. This creates this relentless, super detailed stream of data that tracks every single moment of the production process.
Okay, so with the brains and the messengers all in place, we can now follow a piece of clothing on its digital journey across the factory floor, from just a pile of fabric to a finished product, all ready to be shipped out.
So here's how it all fits together. The clock starts the exact second a tagged fabric bundle enters the cutting station. That's totally automated. But then, look at the middle steps, like sewing and ironing. For those, the worker still has to manually scan a code to say, hey, I'm done with this part. Then, the process ends just like it began, with automated tracking capturing the precise moment the finished shirt hits the packaging station. It's a really smart mix of high-tech automation and necessary manual input.
This system setup really shows you the whole picture. You've got the tags on the floor, talking to the gateways on the ceiling. But all that raw data, updates every half second, is way too much to just send to the cloud. It'd be a mess, totally useless. So there has to be a powerful local server right there in the factory to crunch that massive data stream, turning it into useful, structured info that managers can then check on from anywhere using a cloud platform.
Now, this all sounds amazing in theory, right? But actually putting it into practice isn't as simple as just plugging a few things in. Turning an old-school factory into a digital one comes with some serious, real-world engineering hurdles that you absolutely have to solve first.
Hey, remember that 14.6 meter signal radius we talked about a minute ago? Well, here is where it becomes a real headache. The production lines in these factories are usually spaced about 20 to 23 meters apart. You can do the math, it's pretty clear. One single gateway just cannot cover 2 production lines. Its signal just doesn't reach that far.
So, what's the solution? Honestly, it's brute force. To get full coverage, you need 2 gateways for every single production line, one at the start for cutting and another at the end for packaging. So for a typical factory with 20 lines, that means you're installing a whopping 40 gateways. That is a serious amount of hardware.
And the second major challenge is what I like to call the data flood. All those tags reporting every half second create an absolute tsunami of raw location data. You can't just dump that into the cloud. It would be completely overwhelming and pretty much meaningless. It has to be processed and made sense of right there, on site, and immediately.
And that, my friends, requires some serious computing power right there on the factory floor. We're talking about a dedicated server with at least 16 gigs of RAM and an Intel i7 processor or better. This is not some app running in the background on a desktop. It's a high-performance data processing engine that is absolutely critical to making the entire system work.
So, after you've jumped through all the hardware and data hoops, what's the ultimate impact? This is where we come full circle, right back to that initial problem. The factory literally moves from an era of guesswork to an era of absolute precision.
The new reality is that every single decision is now driven by data. That gut feeling, that years of experience estimation that used to run the factory is completely replaced by precise, second-by-second time data for every single t-shirt that moves down the line.
So why does all this matter? Well, because it solves every single one of those big problems we talked about at the beginning. Labor costs can finally be calculated with pinpoint accuracy. Delivery dates become precise and reliable. Production schedules can be fine-tuned for maximum efficiency. And for the very first time, the business has a true data-backed understanding of its own profitability.
This entire journey started with just a simple t-shirt. It kind of makes you wonder, doesn't it? What other everyday, old-school industries out there are quietly hiding a technology revolution of their own, just waiting for us to notice?